Today, we'll be looking at a plantar pressure recording of some very pronated feet. So much so that the medial longitudinal arch is actually weight-bearing, which is pretty rare. It's been recorded on a Sensor Medica 3-step mat, so we'll be using 3-step 2 as the analysis software. Let's get started. So this is the average view, and we can see that the weight bearing is going from the heel directly through the medial column onto the hallux, more on the left than the right. Moving to the maximum pressure view or peak pressure view, we can really see even more so that's the case on the left, with weight bearing being shown underneath the right first MTP joint that wasn't there in the average view. Why? We can see that when we move to the integral view. The integral view shows the most of the weight bearing timing is in the heel and underneath the IPJ of the hallux on the right foot, and particularly focused under the first MTP joint and hallux of the left foot. And so because the average view is the average of the peak and the integral, that's why we see these sort of features. And this is why I recommend looking at the peak view and the integral view to get a wider picture of what you're seeing. So we'll go back to the average view, and now what we'll do is we'll have a look at what actually looks in a dynamic examination. So what we can see, focusing on the left, that the weight bearing goes from the heel through the medial column onto the first MTP joint, jams, and then finishes with the IPJ. So this stopping it there, we can see that there is jamming at the first metatarsocuneiform joint, causing the functional hallux limitus to occur, and that remains as we move forward for quite a considerable time. So the first MTP joint is not moving. The hallux is not dorsiflexing, it is jammed, and it resolves by finally the weight bearing moving away from the first MTP joint, going through the second and third MTP joints and out through the hallux. If we have a look now at the right foot, we can see the weight bearing comes from the heel, and it's there for quite a considerable time because of the instability of the midfoot and forefoot. And the first major weight bearing through the forefoot is actually at the hallux. Continuing on then, the weight bearing comes through, there is some functional hallux limitus happening, but the weight bearing is going around the first MTP joint onto the second, and finally going through the first, or the IPJ of the hallux, I should say. It is quite possible that the right foot has had the functional hallux limitus for a longer period of time. The body has worked out a trajectory for the force that is reducing the blocking by moving the weight bearing around, but it is still as dysfunctional. So what could this suggest? It could suggest that there is a dorsiflexed first metatarsal on the right foot, certainly a hyperextended hallux at the IPJ, so the IPJ now is becoming the rocker as a person moves over their foot. It also suggests that the foot is collapsing because there is no windlass effect happening, because it can't, because of the functional hallux limitus. It also means that it's going to put a lot of stress and strain on the plantar tissues at the first MTP joint and on the medial soft tissue structures such as the tibialis anterior and posterior, as well as all of the ligaments. It may actually cause, on the left side particularly, sesamoiditis because of the long period of time of high loading that's occurring underneath the first MTP joint. Of course, your examination would actually look into this to find out which of these it is. Let's have a look now at the center of pressure trajectory. So looking at the white line again, Ideally, the weight bearing should come up the lateral column, come across the parabola of the metatarsal heads through the first and second MTP joint. And we can see this is patently not the case in both feet. The lines are straight, there's hardly any bend at all, and it means that the midfoot joints are absolutely dysfunctional. If we have a look at how fluid that weight bearing is, there is some hesitations and blockages both in the rear foot because of the fact that the midfoot joints are not stable, and then again at the forefoot because of the functional hallux limitus, and the pathway has to get around that blockage and through the foot. The peak pressure line, which is really hard to see, is the red line, and it goes from the heel directly through to the first MTP joint on the left foot and the right foot with a slight deviation. And that's where the most weight is going, and we've seen that in the peak pressure view. And the symmetry of speed, well, we can find that out by selecting gait line, or on other versions of software, there's other ways of doing it, and we can see the two little dots moving forward in their speed to see if they are similar in symmetry. And so what we can see, because of the functional hallux limitus blockage of the left foot, which is the green line, we can see that it slows right down just about now where we see the blockage. And it's only when that blockage is resolved we see it speed up again. Looking at the pressure versus time graphs, we can see, not surprisingly, that looking at the left graph, which is on the top, there is far more weight-bearing intensity in the forefoot, the green loading curve, than the rear foot, and for a prolonged period because of the functional hallux limitus. With the right foot, it's more weight-bearing in the rear foot with a shorter, more steep curve on the forefoot, particularly through the first MTP joint and hallux. It's that steepness of the curve that can cause substantial injury as the tissues are onloaded very quickly and not a nice smooth transition that we see in the left. So even though the left foot may be worse in function because of that quick onloading of the tissues on the right forefoot, the right foot might be the symptomatic one. Of course, we can look at the symmetries between the left foot and the right foot, and they look reasonable with those differences I've just explained. Let's have a look at the arch elongation. I'll just pause our video here, and I'll select the weight-bearing line or the loading line of the first MTP joint, and I will unselect the midfoot and forefoot, and we can see that the arch elongation on the left foot is 284 milliseconds and the right is 412 milliseconds. So this again gives me the feeling that the right foot has been dysfunctional for a longer period of time, not only because the body's pathway resolution is more efficient, but the arch is elongating more. And again, it wouldn't surprise me if there was some sort of symptoms in the right foot where they may not be in the left foot, simply because of those changes I've mentioned. So looking at this, it gives us an understanding of what's going on right now. The question is, why is it happening? Is there soft tissue contractions? Is there joints, functional subluxations through the midfoot that is causing this? Is there huge muscle weakness that of the muscles involved? And once we've worked those things through, we can then start employing interventions to change the function of the foot, whether it be mobilizing, soft tissue release, functional taping, what have you, and then re-record and actually see what changes. I hope this has been helpful to you. Please don't forget to ask any questions you like and put them in the global community on Facebook so that I can answer them and we can all learn. And that includes me too. See you next time.